Hi class, in this lecture here we're going to begin talking about our section on financial mathematics by looking at the topic of interest. And you've seen this topic before in your daily life, or obviously you've heard of interest before, right? Like when you put money in a bank account, it accrues interest. When you take out money, borrow money to buy a car or your first house, you have to pay interest on the amount that you borrow. And so in this lecture here, what we're going to do is we're going to talk about three different types of interest. We're going to talk about something called simple interest. Now, simple interest is not an interest that's used in practice in the real world, but it's a great introduction to the next two. So what we have is something called compound interest, and then we're going to end on something called continuously compounded interest. And for this lecture here, you're going to need your graphing calculator as we go through this. Basically every single problem we do will involve me using the graphing calculator. So have that handy as you go through. Okay, so let's jump right into it. Simple interest. So there's going to be some words that come up, in every type of problem we do. Okay, and so I want to put letters or variables to this. Okay, so simple interest. So the first concept we have is what's called interest. So interest is the dollar amount. All right, it's the total amount that we get paid for lending money or pay for borrowing money. So interest in our lecture is just always going to be denoted with the letter I. Okay. So the amount of money then that we deposit into a bank that the bank's going to pay us interest on, or the amount of money that we borrow to buy that car, let's say, is called the principal. Okay, the principal. So that's going to get the letter P. All right, the amount of interest depends on the principal and the interest rate. Okay, so the interest rate, all right, that's going to be given with the letter R in our lectures. All right, is given as a percentage and varies from bank to bank, then length of time for which the money is deposited. So it's going to be given as a percentage, but when we put into the problems or put into the formula you'll see in the coming slide, all right, put as a decimal. So, for example, if something has like 5% interest, we're going to write it as 0.05. All right, so we have the interest is the dollar amount we're going to get paid or have to pay to borrow money. Principal is how much we deposit or borrow. Think about it. Also, you can think about it as like the starting value. We have the interest rate, okay? And so what we have now is what's called simple interest. All right, so simple interest involves interest calculated only on the principal. All right, no interest on interest. Okay, the interest on interest is how things are done in the real world, but this simple interest is just going to involve interest calculated only on the principal. All right, so to calculate simple interest, all it is it's very, very easy. The interest is equal to the principal times the rate times the time. So interest I is equal to principal times rate times time. The rate R, I said, is expressed as a decimal when calculating simple interest. And the time, T, so we have this new variable T here, all right, that's for time, all right, is expressed in years. Okay, so T is always the number of years. I'll talk about problems, where we think about it in terms of months, but we'll start with years. It'll be very, very simple. All right, so interest is equal to principal times rate times time. All right, so here's the first example of using simple interest. Suppose you deposit $2,000 in a savings account at Hometown Bank, which has a rate of 6%. All right, find the interest at the end of the first year. All right, so you're going to deposit $2,000. So that means your principal, which is P, is $2,000. Okay. You have a rate of 6%. So remember, you just have to write that as a decimal. And then you have this time. Okay, that's the letter T. Well, we want to just figure out at the end of the first year. So that's just when T is equal to 1. All right, so interest is equal to principal times rate times time. So you're going to take $2,000 times 0.06 times 1. All right, so let's figure out how much interest you got at the end of that first year. So we're going to go 2,000 times 0.06 times 1. So you made $120 at the end of your first year, okay, by just leaving that money in the bank. All right, so after 1 year, you made $120 in interest. Not bad. Not bad. All right, let's try another one. So a student took out a simple interest loan for $5,000 for 2 years, all right, and at a rate of 6%, okay, and this was used to purchase a used car. Let's find the interest on the loan. All right, so again, principal. How much did the student borrow? Okay, that's the letter P. The student borrowed $5,000 to get a used car. The rate was 6% again, so that's 0.06. And look, they did it for 2 years. So time, T, is the number of years. It's 2 in this case. So you're just always going to use that formula. They tell you right here, simple interest loan. Okay, so that means the interest is equal to the principal times the rate times the time. So that's going to be $5,000 times 0.06, now times 2, because we're doing it for 2 years. So again, grab your calculator here. You go 5,000 times that 6% times 2 years. So that student is going to have to pay $600 in interest to borrow this money. So the interest after 2 years was $600. All right, not too bad. Hopefully the student here likes the car that they got here. All right, let's introduce a new formula here. Okay, so we've got this basic one. So this problem here just solves for the interest. All right, so now the future value, A. Okay, so we're introducing this new variable. A is the future value of P dollars at simple interest rate R as a decimal for T years is given by. All right, so the future value, A, is equal to the principal, P, all right? This is also known as the loan's present value. Think about it as the starting value. Is equal to, now this is important. This is the number 1 here. It looks like an I, but it's the number 1. So 1 plus R times T, okay? All right, so this is the total amount. So think about this, what this formula gives here, all right, is this future value gives here principal plus the interest, okay? Principal plus the interest. That is what is considered the future value of the loan. Principal plus interest. All right, let's do a problem here. Ooh, so this is interesting. All right. So a loan of $1,060 has been made at 6.5% for 3 months. So this is interesting. So here's the 3 months part now. Remember, T is number of years. But this is 3 months. Ugh, I'm not sure how to handle this. All right. So, obviously, I'm going to tell you. Okay, so find the loan's future value. Okay, so that's just going to be this formula. A is equal to principal times 1 plus the rate times time. Okay. All right. Well, look, I've got P. Okay, that's the $1,060. Okay, so the principal is $1,060. The rate is 0.065. Okay, now t, time, this is interesting. So you have to write 3 months in terms of years. Well, that's 3 months would be 3/12 of a year. So what is 3 divided by 12? Well, that's just 0.25. So if you're ever given the number of months, okay, so just note. The number of months divide by 12. So divide that number by 12 to convert to years. Always, always, always do that. Okay. All right, so now we're ready to use the formula. The future value of the loan, all right, which is the principal plus the interest, okay, is 1,060 times 1 plus 0.065 times 0.25. All right. At this point, you can just grab your calculator. And what's awesome is if you watch me, I'm going to do this all in one step in my calculator. So I'm going to go 1,060 times, and then in parentheses, 1 plus 0.065 times 0.25, and close the parentheses. All right, you can also do this step by step, doing the multiplication first, then add 1 to it, and then doing the outside multiplication. But with these graphing calculators, what's amazing is you can do this all in one step. And look, this is what we get. $1,077, and I'm going to round this to 23 cents, obviously. Rounded to 2 decimal places. For cents, obviously. Okay, awesome. Awesome. All right. Let's do let's mix it up a little bit. Let's do another example here. So let's talk about this one here. So you borrow $2,500 from a friend and promise to pay back $2,655 in 6 months. Okay. What simple interest rate will you pay here? Okay, so we have there. You could use this. What's really great about this problem is you could solve it using either the future value formula, this one, or you can solve using the simple interest formula. Okay, I'm going to show you. We'll do both. Okay, so this right here. This is my P. This is the principal. Okay. This right here. This is the future value. This is how much you're going to pay back, okay? And they're telling you 6 months, okay? So remember, you got to write that in terms of years. So that's 0.5, okay? That's half a year. So what simple interest rate will you pay? So what they're asking you to solve for R. All right, so let's try this formula. A is equal to the principal times 1 plus the rate times time. Okay. Well, look, I've got 2,655 is equal to my principal times 1 plus the rate, which I don't know, that's what I'm trying to find, times 0.5. All right, so if you wanted to solve this, what you would do first is let's get rid of this 2,500 in the front here. So let me divide by 20 each side by 2,500. So 2,500 cancels. So you would take 2,655 divided by 2,500. You get 1.062. equals 1 plus, I'm going to put this in front, 0.5 times r. So look, subtract 1 from each side because you want to get r by itself. So here you get 0.062 is equal to 0.5 r. Divide by 0.5. Let's see what we get. So I subtracted 1. Divide by 0.5. And I got a rate of 0.124. So look, what we're saying here is, wow, you paid a 12.4% simple interest rate. Yikes. So look, you could also solve this using this formula, right? Interest is equal to principal times rate times time. Well, look, if you have $2,500 and you're paying back $2,655, how much total interest did you pay? Well, you know, just figure it out, right? Just go like this. Just go, okay. 2,655 minus 2,500. Okay, and you paid a total of $155 in interest. So that's that's interest, is equal to your principal, 2,500, times your rate, which you're trying to figure out, all right, times your time, which is 0.5. All right, we'll take 2,500 and divide it and times it by 0.5. You get 1,250. And then just divide by 1,250. And look, 155 divided by 1,250. You get the same thing. So you could have used either form, like either formula worked great here. All right. Let's get the same thing. All right, now let's talk about compound interest. Okay, where either you're getting interest on top of interest, or you're paying interest on top of interest. This is more how things are done in the real world. Okay, simple interest was, you know, good introduction to interest. But now let's talk about compound interest. Okay. So compound interest is interest computed on the original principal as well as any accumulated interest. All right, so to calculate compound interest paid, now first we'll start with once a year. All right, we use this formula. A, which is the account's future value, is equal to the principal times 1 plus r raised to the t. Okay, and this is important. This formula is for once a year. Okay, once a year. We'll talk about if it's done differently. Okay, but this was just for once a year. All right, so A again is the account's future value, P is the principal, R is the rate, and T is the number of years. Okay, number of years. All right, so let's do one example of this, and then we'll talk about a little bit more where it's, more than once a year. All right, so here's the problem. You deposit $2,000 in a savings account at Hometown Bank, all right, which has a rate of 6%. Find the amount A of money in the account after 3 years, subject to compound interest. Okay. So look, we have this formula. A is equal to the principal times 1 plus the rate t, raised to the t power. All right, P here. Okay, this is my principal. This is how much I'm starting at. This is my rate, okay, but as a decimal, 0.6. And this is my t right here. It's 3 years. All right, so look, you're going to go 2,000 times 1 plus 0.06, right, raised to the third power. All right, so this is going to be 2,000 times 1.06 to the third power. All right, so then watch my calculator. Okay, I'm going to do this all in my calculator here. So 2,000 times 1.06, and that 1.06 is raised to the third power. All right, well look, all right, after 3 years, okay, and you always remember dollars and cents. You're going to round this to 2 decimal points, right? So it's $2,382.03. All right, so now you have to figure out the total interest you got, okay? And to do this, one way you can find out the interest is you take the future value which is the letter A, and then you just subtract the principal, your starting value. Right? Because if you started with $2,000 but you ended up with this, anything past that $2,000 is the interest. So it looks like over this 3-year period, you made $382.03 in interest. Okay, not bad. Not too bad at all. All right. So once a year, it isn't generally, how interest is done, right? So like think about, in my bank account, right? I get interest deposited every month. Okay. So now what we're going to talk about is when it's compounded more than one time a year. Okay, so once a year, you're compounding it once every year. But now it's going to be like, what if it's every month? What if it's every quarter? So we got to modify the formula just a little bit here. All right, so here it is. If you deposit P dollars, okay, so again, that's your principal, at a rate R in decimal form, subject to compound interest paid N times per year. All right. So for example, if it's done monthly, that would be N is equal to 12 because it's 12 times a year, right? Then the amount A of money in the account after T years is given by this formula here, okay? A, the amount, is equal to the principal times 1 plus R divided by N raised to the N times T power, okay? Here, this A is called the future value, and the principal P is called the present value. So in today's dollars, or think about it as the starting value. Okay. All right, it's a little bit more complicated. You'll notice really what's going on here is the difference in the formula here is you're taking rate, you're dividing it by N, and instead of just T, it's N times T. All right, let's do some problems here. All right, so you deposit $7,500 in a savings account. Okay, so that's your P. That's your starting value. Okay, that's your principal. That's how much you're depositing into a saving account that has a rate of 6%. So that's my R. Right, and the interest is compounded monthly. Okay, so how many times per year is that? Well, that's 12 times. All right, how much money will you have after 5 years? Okay, so that's my T. All right, that's the number of years. So to figure out how much you'll have after 5 years, you're going to use A, the future value, is equal to principal times 1 plus R divided by N raised to the N times T power. All right, again, what are you doing here, right? You're just taking all these values and plugging it into the formula. All right, so A is equal to the principal, which is 7,500, times 1 plus the rate, which is 0.06, and you're compounded monthly, so it's 12. All divided by n times t, so this would be 12 times 5. All right. If it helps for you to clean this up, go on ahead and clean this up, okay? So watch. So you can go 0.06 divided by 12 plus 1. So the inside of this parentheses is 1.005. And 12 times 5 is 60. Okay. So this is important. Like, you have to remember your order of operations. Like, you wouldn't go, oh, let me take 7,500 times 1.05. No. Right? It's parentheses. Now you got to do the exponents first. Okay. So again, your calculator will do the correct order of operations if you have these TI calculators. So I'm going to go 7,500 times 1.005 raised, so it's raising that to the 60th power. And look, okay, after 5 years, wow, this is really good. This is pretty good. I'm going to have $10,116.38. So $10,116.38. Right, that's not bad. It's pretty good. All right, so how much money did I make in interest? Well, interest is equal to the future amount minus the principal. So you're going to take $10,116.38, and you're going to subtract away that $7,500 you started with. So $10,116.38 minus 7,500. Oh, you did pretty good. Okay. After 5 years, how much money did we make in interest? We made $2,616.38. So not bad at all. Okay. So again, just as you're seeing what I'm doing with all these problems, right? Like I'm pausing, I'm circling off the right information. I'm saying, oh, the 7,500 is the P, the 6% is the rate, and I'm going from there. All right, let's do another one here. All right. So a certificate of deposit, a CD, all right, is a savings instruments that many banks offer. Yeah, for example, if you go to your bank, let's pick Chase or Bank of America, whatever, and you go in, you can purchase a CD, all right? And what it does is it usually gives a higher interest rate, but you cannot access your investment for a specified length of time. Okay, like if I buy a CD for 3 years, I can't touch that money for 3 years. All right, so suppose you deposit $3,000. Okay, so that's your principal. In a CD paying 6%, so that's my rate, compounded monthly, okay? So that's 12 times per year. How much will you have in your account after 20 years? So T, that's a 20-year time frame. So that's a really, really, really long time, okay? So look, you're just going to use the future value. I want to figure out the amount after 20 years is equal to the principal times 1 plus the rate divided by the number of times compounding raised to the n times t power. So that's $3,000 times 1 plus 0.06 divided by 12 raised to the 12 times 20. All right, well, we did this in the previous problem. I picked the same thing. So we know that 1 plus 0.06 divided by 12 is 1.005. So it's 3,000 times 1.005. And you know, what's 12 times 20? That's 240. So let's see, after 20 years, so like if you deposited at 20 and you turn 40, you know, how much will you have, you know, on your 40th birthday here, okay? So you're going to go $3,000 times 1.05 raised to the 240th power. I looked at it. I was like, wow, that's too much. I forgot a zero there. So 3,000 times, it did look ridiculous to me there. 1.005. There we go. Raised to the 240th power. Sorry about that. Yeah, this looks much more reasonable. See, so notice, you know, when you get your results like this, you know, just, hey, does that look like it makes sense? No. So I noticed I forgot a zero. So this is $9,930.61. So not bad. And you look, you can very quickly see that you made over, you made $6,930.61 in interest. So pretty good. All right, let's do another compounded one, and this one I'm gonna make it I don't know, a little bit more interesting, maybe a little bit harder. Let's see. All right, so here's the problem. So I have a young son. All right, at the time I'm recording this video, so we'll pick me as an example. Okay, so suppose so you know that I'm going to need $50,000 for my child's education in 18 years. Okay, if your account earns 5% compounded quarterly, how much would you need to deposit now to reach your goal? Okay. So look, here's what's going on. I need to know how much I need to deposit now. So this problem is asking you to solve for the principal. So let's see what we're given, okay? This $50,000 is how much I'm going to need in 18 years. That's the future value, okay? So you're given the future value you're going to need is $50,000, okay? For my child's education in 18 years. So I'm given T is equal to 18 here. If your account earns 5%, so that's the rate, compounded quarterly, so every 3 months, okay? So the number of times then, how many quarters are there in a year? So it would be compounded 4 times. So I've got to take my equation. The amount is equal to the principal times 1 plus r divided by n raised to the n times t, and see if I can somehow solve for p, okay? All right, so let's see. 50,000 is equal to my principal, which is what I'm looking for, times 1 plus 0.05 divided by 4 raised to the 4 times 18 power. All right, so we're going to have to clean this up. All right, 0.05 divided by 4 plus 1. So I got 1.0125. 1.0125. And 4 times 18, you know, if you need your calculator for that, right? It should be 72, but okay, 72. All right, so look, leave it like this for now. All All right, what you want to do to get P by itself is you're going to divide both sides by this number, whatever this is. And watch how I do it in the calculator. Okay, so these are going to cancel. All right, so I'm going to get 50,000, or excuse me, P, the principal, is equal to 50,000 divided by this number, 1.0125 to the 72nd power. All right, let's grab our calculator, see how much I'm going to have to deposit now. All right, so I'm going to go 50,000 divided by 1.0125 raised, so I'm just making sure it only goes to that, to the 72nd power. Oof. So right now I'm going to have to deposit $20,442.20. And so look, if you need to, by the way, if you need to figure out, like, for example, if you know this ahead of time, so 1 point, depending on your calculator, you're going to get a number that's, you know, doesn't have a non-repeating decimal here. So, you know, you're going to have to go out 4 or 5 decimal points if you want to do it, not how I did it, okay? All in one step in your calculator. Your answer, if you do that, will be slightly different. It'll be off by a few dollars or cents or something, but, you know, if you can follow this way here, it'll be, it's you know, it's a little bit easier. So I'm gonna have to get that money into my son's bank account right now to get ready for his education. All right, let's now talk about something called, so we've got simple interest, compound interest. Let's now talk about something called continuously compounded interest. All right, so what is continuously compound interest? So continuous compounding is the mathematical limit that compounded interest could reach if it's calculated and reinvested into the account's ballast over time, a theoretically infinite number of periods. What does that mean? That just means if I put you know, $1,000 into a bank account, okay, and it just sits there, this would be like if it's getting interest every single second of the day, every single millisecond of the day, where that you leave it invested in the bank. It's calculating the interest here. Okay, so what's going on here, if you look at our formula, it would be when n is, you know, infinity. Okay, but like how could you divide r by infinity, or, you know, infinity times t? Like what happens there? Well, it turns out it converges to this formula here. The amount is equal to, so the amount, the future value, is equal to the principal, initial value, times e, okay? All right? And look here, this E is right here on your calculator, okay? This number E here. You know, so what is E? E is the number 2.718281828. It's just a number, okay? And it turns out that, you know, basically it's the, you know, this limit, okay? It's the limit as n goes to infinity of 1 plus, you know, r divided by n raised to the n power, okay? It's, you know, if you take calculus, you'll learn a little bit more about it. But for now, it's just a number, okay? And I'm going to show you how you work problems in our calculator using this, okay? So R is that interest rate, and T is time in years, okay? All right, so let's use this formula. Okay, so this is a theoretical formula, right? Where if it's compounded every millisecond, you know, continuously nonstop at every possible second in time. Okay. All right, so here's the problem. If you invest $1,000, okay, so that's my P, at an annual interest rate, so my R is 5%. Compounded continuously. So whenever you see that continuous amount, word continuously, compounded continuously, you're going to use this formula. A is equal to P times E raised to the RT power. Calculate the final amount you will have in the account after 5 years. All right, so watch. Compounding continuously. A is equal to the principal times e raised to the r times t power. So it's $1,000 times e. Oh, I wrote t as a decimal here. Sorry. E raised to the 0.05 times 5. Let's see what we get. So here's how you're going to have to do this. You're going to go, if it helps you to do this ahead of time, like 0.05 times 5. So you can get that part out of the way, that's 0.25. Maybe that makes it a little bit easier. So we're going to go $1,000 times, and then in your calculator, you got to look for that E, and then you're going to raise E to the 0.25. And look, all I would have after 5 years is I'd have $1,284.03. And that's it. Very, 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 very simple here. All right, let's do another one so you can get used to the formula here. Oh, okay. So you invest $20,000. Okay, that's my P, my principal, at an annual interest rate of 1%. So very low, very, very low. So that's 0.01. Compounded continuously. All right, calculate the final amount after 20 years. All right, so whenever I see this compounded continuously, it's P times e to the RT. So after 20 years, it's a pretty low interest rate. 20,000 times e raised to the 0.01 times 20. All right, so if it helps, do it's 0.2. So you're going to go $20,000 times e raised to the 0.2. Okay, well, that's a long, you don't have that much more, and this is just because of like a really, really low interest rate here. So you'd have $24,428.06. $428.06. All right, let's do a problem now. Let's end on a problem here where we compare all three interest rates, okay, or all three types of interest, and you can see like which one is going to be the best, okay. All right, so here's the problem. Suppose you invested $1,000, okay, so this is my principal, in a CD that pays 5%, so that's my rate, for 4 years. Okay, so that's T is equal to 4. Find the total amount you'd have if the interest was calculated. So I'm asking you to find the total amount, so the future value. The interest was calculated using simple interest. All right, well, the formula for there, you can even go back. All right, future value, this is simple interest, okay, is equal to principal times 1 plus R times T. All right, so look, this is just $1,000 times 1 plus the rate, which is 0.05 times 4. All right, well, let's see how much we'd have, okay? This is just simple interest, all right? So it would be 1,000 times, then in parentheses, 1 plus 0.05 times 4, close the parentheses. So after these 4 years, you'd have $1,200, right? You know, which makes sense, right? Because you'd be getting $50 in interest a year here. All right, now if it was compounded monthly, let's see. So this is the amount is equal to the principal times 1 plus the rate divided by n times raised to the n times t power. Okay, so this would be my principal, okay, which is $1,000 times 1 plus my rate 0.5, but here now it's times divided by 12, okay, because I've compounded monthly, so this would be n is 12 raised to the 12 times 4. So look, if you need to do this, right, so you can go 0.05 divided by 12. Okay, and notice when you get a problem like this, okay, watch how I do it. So you notice how I get, you know, a non-repeating decimal. I'm going to add 1 because I'm plus 1. And then I'm going to raise that. Well, what's 12 times 4? That's 48. And then I'm going to times that by 1,000. And look, I got more money. I got $1,220.90. So I got, I made an extra $20.90 here, which is, over time and with a larger amount of money, it really adds up. So if it's compounded continuously, this is just P times e to the RT. Well, look, simple interest, compounded monthly, you got more. Well, let's see if it's compounded continuously. Let's see if that's even more money. So it's 1,000 times e to the rate, which is 0.05 times 4. So if you go 0.05 times 4, right, you get 0.2. So this is 1,000 times e to the 0.2. Let's see what we get. Look, you got an extra little bit more. So compounded continuously, it's even more money. It's $1,221.40. All right. So hopefully you can see here that the more times you compound it, it's more money. Okay, so the most interest here, you get more interest when continuously compounded. All right, class, I hope this lecture helped, right? The hard part is, pay attention to the formulas, make sure you know what's being asked. And, as always, if you have any questions, I'm here to help.